So in this video I'll talk to you guys a little bit about converting between different types of concentration units. And when I say different types, I mean things like molarity, moles per liter, moles per solute over liters of solution. Molality, moles per solute over kilograms of solvent. Mole fraction, the representative number of moles of solute or solvent divided by both. ppm, of course, parts per million. ppb, as you would know, parts per billion. Percent by mass and percent by volume. Percent by volume you might have actually seen before. You'll find this on pretty much every bottle or can of alcoholic beverage, whether it's wine or beer or moonshine or whatever your preference is, assuming you're of legal age, of course. If you were to look at, for example, a bottle of Jack Daniels, for example, that will be 40% alcohol by volume. That means 40% alcohol, 60% water. All right. If you were to pick up a bottle of this dangerous stuff called Everclear, that's 90% alcohol, 10% water. Everyone to his own, I suppose. Anyway, so let's look at a question like this one. It says, what is the molality? So this is what we're being asked to find, is molality of a solution of glucose that its only concentration term we're given is 10.5% by mass. Now, the only way we're going to be able to understand this is if we can somehow convert this percent into something that we can use. Alright? Because we can't really use this percent unit. We've got to convert it into something that's going to allow us to get moles, for example. Alright? And if we want moles, of course we want grams. So we've got to find a way to go from here to grams first. So let's just write out what we understand by 10.5%. Of course, 10.5% of anything means 10.5 out of 100. And that's exactly what this means. The only real difference between this and the percent you see in your average math class is the fact this is talking about by mass. Which means if our solution weighed 100 grams, then how many grams of that would be glucose? Well, of course, it would be 10.5 grams would be glucose. Alright? Now, this actually tells us two things. It allows us to say, well, this is it in grams, I can convert this glucose into moles, which is one thing I want to do. But it also allows me to figure out how much of the solution is water. Because if 10.5 grams of my solution is glucose, then all the rest out of that 100 must be water. And of course 100 minus 10.5 is 89.5. So therefore 89.5 grams of that solution, whatever is remaining, is water. And this is useful because I need both of these. I need the grams of my solute, which is glucose, to get the moles of the solute. I need my grams of water because I need to calculate my liters of solution. Not my liters of solution, my liters of solvent, which in this case is water. Alright? So let's do the glucose first. We're going to convert this 10.5 grams into moles. Okay? So we know 10.5 grams, I'm just going to say G for glucose. And we're going to do the usual conversion factor that we do, where we have, when we're going from grams to moles, we put 1 mole of whatever on the top, and then the number of grams on the bottom. Okay? Now we know carbon is essentially approximately 12 grams per mole, hydrogen is approximately 1 gram per mole, and oxygen is approximately 16. So what that means, approximately, is 72 grams per mole for our carbon, because we've got 6 of those, 12 grams per mole for our hydrogen, and 6 times 16 is 96. For our oxygen, if we add all those together, it's 96 plus 12 is 108, plus 72 is 180 grams of glucose in 1 mole. And so what we get is, essentially, this isn't exactly the answer because I haven't used the more accurate number of significant figures in my atomic weights, but it'll give you the right idea. It gives you 0.0583 moles of glucose. And we need that because we know molality is moles per kilogram. So we have our moles of our solute, but we still need the kilograms of our solvent. And the only thing we have to go off is this 89.5 grams. Alright? So I know I have 89.5 grams of my water. And we want to convert that into a... Let's see, we want to convert this into... Actually, we have it in grams already, so we don't really need to do much at all. Because I'm assuming everybody remembers how to go from grams to kilograms. We know in every kilogram there's 1,000 grams. So therefore 89.5 grams is actually 0.0895 kilograms, in this case of water. So when I figure out my molality, then I'm going to do my moles of my solute over my kilograms of solvent. So therefore, what we can say is 0.0583 moles of our solute divided by, in this case, 0.0895 kilograms of our solvent is going to give us 0.652 moles per kilogram, or we could just say M. That is the molality of our solution. So what we've done is we've gone from one concentration unit, that's 10.5% by mass, and converted it into molality. And really I could calculate pretty much most of these other concentration units. I would need probably some other things to be able to do that, like, density of the solution, for example, for molarity, but it's not that much of a stretch to go from one concentration unit to another. Okay, thank you.